Hello everybody, this is the video for day 4, two-way tables. I'm going to try to shorten these videos up just a bit for you guys. With that being said, please keep in mind that whenever you are doing a video, you can stop, play, replay whenever you'd like. To start out, we're going to take a look at this building a new high school question. Go ahead, stop the video, read over the question in your notes, and come back when you're ready. So as you can see, we are building a new high school. And what I'm going to do is I'm going to simplify what's in this table. And I would have done this with you in class. However, just try to shorten this up to give you the most important information. I'm going to shorten up this table into what we call a two-way table. Turn the page. Again, hit pause and copy down all of this information. So this is the result of a vote on whether or not we're going to build a new school building. So given that this is given information, you wouldn't have to come up with that on your own. A two-way table is just a way to organize information to make it easier for people to read and understand. A two-way frequency table takes a look at two variables here. In this case, a yes and a no, for example. So what we're going to do now is basically answer questions below based upon this table. Many of you will probably find this pretty simple. So go ahead and read over this small paragraph again, hit pause, and come back when you're ready. So to see if these headings are accurate, let's start looking through the information. Waldo voters likely support building a new high school. In order to see if that's really an accurate statement, we've got to take a look at who supports building a new high school. That would be the people that vote yes. So there's 273 people out of a total of 515 people. So in order to see if that's likely, you can divide that through. 273 divided by 515. And that number, if we just bump over the decimal point 2 spots, would be about 53%. Or you can take this number, multiply it by 100, that would also give you the percentage. So about 53%. So that heading would be accurate. We consider a majority about 50% or higher. The next headline, older voters are less likely to support building a new high school. There's some room for interpretation there. What do you think is older? If you're asking myself, I would probably consider 66 and older, the older category, if you will. So I just looked at that. There are a total of 33 people that would support it out of a total of 88. And if I were to do that math, again, you can just divide it out and look at the percentage. That's about 37.5%. So again, considering 50% is usually our cutoff point, I would say that that is an accurate statement. Now, if I'm asking all of you, and you guys are, in your teens, what you consider older, you might consider older 41 and above. So that heading, again, has room for interpretation. But if we consider it 41 and above, let's see if that is still true. So the number of yes voters, 41 and above, so that would combine these two categories. 66 plus 33 would be 99 out of a total of 237, and that will be from adding up these total numbers here. So out of 237, again, divide that through with your calculator, and that will come out to about 41.8%. And again, not close to that 50% marker. So I would say that this is also accurate, this heading. That older voters, whether you consider it to be 41 and above or 66 and above, are less likely to support building a new high school. Heading number 3, younger voters are not interested in building a new high school. Well, I think younger voters would probably definitely be the 18 to 25 category. And again, you might consider 26 to 40 younger. There's room for interpretation, which also helps you to start thinking of, whenever you see a heading in a paper, the person writing it is writing from their perspective. So what they consider older or younger might be different from what you consider older or younger. So if I look at 18 to 25-year-olds and how many would support it, for example, there are, looking back at the table, 61 that would support it out of 75. So 61 out of 75. Again, divide that through in your calculator. It's about 81.3 repeating percent. So that's what supports it. That's well over 50%. So this heading would be not accurate. Just goes to show that you should always investigate what you're reading. Not everything you're reading is always accurate, whether it's in a paper or any other sort of news media. There's another problem I'd like to do is on the next page. And it looks at a two-way table in a slightly different way. So again, pause the video and read through this. Come back when you are ready. So in this table, we've actually got to do some work on our own over here because the table of values are not filled in. This table is called a hypothetical 1000 two-way table. It's just basing the information given on a hypothetical 1,000 person population. And the reason why we're doing that is because in this table, we're not given an exact amount of students that have asthma. We're given the probability that a student selected has asthma. So just to quantify this and put a number to it, we're using a hypothetical 1,000 two-way table. So that means you can see the total is 1,000 people down here. So if we hypothetically ask 1,000 people these questions, it's saying that the first bullet, the probability of randomly selecting a student at this high school and having asthma is 0.193. So a student having asthma would be in this category here, cell 3, because it's all students that have asthma, not just the ones where there's no household member smoking or one member smoking. So the way to figure out the number that goes over here is you can take 0.193 and you can multiply it by 1,000. You can also just say, hey, this number is 0.193 thousandths. That number there is a thousand spot. So if I were to write it in terms of 1,000 here, it'd just be 193. The next piece of information we could fill in, second bullet, is the probability of a student having at least one member in his or her household who smoked. So if we look at that number would be this one right over here. It's just anyone who smoked. So 421. The other number that we can type into or write into the table here to start is in the last bullet. The probability that a randomly selected student has at least one household member who smokes and has asthma. So has asthma, at least one member smoking, that's cell 2. That'd be at 120. And again, you could do 0.120 times 1,000 just like I did here. So now it's up to us to fill in the other numbers over here, but we can do that. So if this is 1,000 and this is 193, just subtract 1,000 minus 193 and you'll get the number in this box over here, 807. Feel free to pause the video at this point and try to fill in the table on your own and come back when you're ready. The next one I could easily fill in would be 421 minus 120. That's 301. Now it looks like this entire row is here, or the column is empty. It might be difficult to do, but don't forget these columns add up horizontally as well as vertically. So if we have a total of 193 horizontally, subtract 120, we've got 73 here. 807 total minus 301 gives me 506 here. And then you could add these up to get 579 here. When you're done, this vertical column should total 1,000. This horizontal column should total 1,000. So now we're just going to, again, answer some questions based upon the table that we've got here. So if I look ahead to 9A, go ahead and read that question. So we are randomly selecting a student with asthma. So a student with asthma would be this row right over here. 193 students total have asthma. And we want to know, of the students who have asthma, what's the probability that the student has at least one household member who smokes? So out of a total of 193 students who have asthma, there's 120 of them, oops, excuse me, I know it's not off the screen there. There's 120 of those students that have at least one household member that smokes. So if I want to figure out the probability, again, just take your calculator and divide out those numbers. 120 divided by 193 is about 62%, okay? So this one just said, don't write it as a percent. It said to write it as, oh, I'm sorry. I didn't say where to round to. So wherever you rounded to would just be fine by me. So about 62%. The next question, a randomly selected student does not have asthma. Okay, so now the focus over here is the students that do not have asthma. So that would be 807 students that do not have asthma. That, in other words, is my denominator. So of those students, we're looking for the probability that the student has at least one household member who smokes. So that is 301. So 301 over 807 would come out to about 0.73, or as a percentage, you could write that as, about 37%, or wherever a question is rounded to. And I'll do one more with you guys. 9C, a randomly selected student has at least one household member who smokes. What's the probability that student has asthma? So we're looking at, in this question, the students who come from a house that smokes. So that's 421 students that come from a house that smokes. That, in other words, is our denominator. We're looking to choose a student that has asthma out of that number. So out of that number, there's 120 students that have asthma out of a total of 421. So if I were to divide that through, it comes out to about 2.85, or roughly, if you want to round to the nearest percent, about 29% of the students that have that. So looking at a 2A table for many of you might be pretty simple to do. Make sure that tomorrow you're working on the homework assignment for day 4, and if you've got any questions about either the lesson or the assignment, make sure you email Mr. Kenzie or myself. And don't forget that tomorrow the answers will be posted for the homework assignment that pertains to day 4. Have a good night.